All right, here's our video on the units 5 and 6 diagnostic. I'm going pretty quickly here. So we have 1/3 to the 2 minus x equals 27 to the 3 plus x, and we'd like to solve for x. We should notice that 3 and 27 are from the 3's family. So 1/3 is 3 to the negative first. 27 is 3 to the third. And I now have common bases because they were in the same family. And at this point, the exponents are equal to each other as long as we can get them solidified. So I would have to take my -1 and multiply by 2 minus x. So I'd have 3 to the -2 plus x after I distribute equals 3 to the 9 plus 3x. So I know -2 plus x equals 9 plus 3x. I will, let's see, subtract x from both sides and subtract 9 from both sides. And then we will get -11 equals 2x and divide by 2. And so x is -11 over 2. All right, number 2. We have log, we want to solve this equation. We have log of x squared plus 3x is 1. Reminder, if I have log with no base, it means we have log base 10. And here I can rearrange this equation without writing the log because I can take my base, raise it to the exponent. That's what a log is. A log equals an exponent. And that equals the argument of the log, or the thing that was inside the log. And now I have a quadratic that I can solve. We can subtract by 10 on both sides. So I get 0 equals x squared plus 3x minus 10. And I can factor this into x plus 5 times x minus 2. I get x equals 5. -5, and x equals 2. Those are my solutions. I just have to check and make sure that they actually produce a positive value in for the log. So -5 squared is 25, plus 3 times -5. 25 minus 15 is 10, and log of 10 is in fact 1, because 10 to the first is 10. So 2 squared is 4, plus 3 times 2 is 6. That is also 10. We're good to go. Both of these solutions work. All right, number 3, we have 6 to the 2x minus 1 equals 9 to the x. This is not a families problem because 6 and 9 are actually not in the same family, although they share factors, but they're not in the same family. So this guy I'm going to have to do, and I'm pulling up the calculator as you can see on the screen. We're going to need a calculator at some point here. This guy I'm going to have to do by applying a log to both sides. And by the way, you could have also done number 1 by doing this technique, but number 1 is a lot shorter if you don't use logs. Anywho, so I'm going to take the log on both sides of this, and I get the exponent. The point of this is the exponent comes down. That's a property of logs. So I get 2x minus 1 in parentheses, log 6 equals x log of 9. And log of 6 and log of 9 are numbers. We need to keep that in mind. This is a number, and this is a number. So keep that in mind as we do this problem. I'm going to distribute my log 6. So I'm going to get 2x log 6 minus 1 log 6. That looks like 11 log 6, excuse me. 1 log 6 equals x log 9. And then I'm going to subtract the 2x log 6 over because I want to get all the x's to one side and all the non-x's to the other. So I'm going to subtract 2x log 6 from both sides. And I'm left with -1 log 6 equals x log 9 minus 2x log 6. And then on the right-hand side, what I can do is I can factor the x out. And then I'll get -1 log 6 equals x times log 9 minus 2 log 6. And I can divide both sides by log 9 minus 2 log 6 because the x and the log 9 minus 2 log 6 are connected by multiplication, so we can divide to undo them. And so I get x is this monstrosity. I get x is -1 log 6 over log 9 minus 2 log 6. And I believe I asked you to round this to the nearest hundredth. So on your calculator, you would have a calculator for a question like this on your final. I can press alpha, y equals enter to produce a fraction. I think it's much easier to do it this way. -1 log 6 divided by log 9 minus 2 log 6. And I get 1.292. So if I'm rounding that to the nearest hundredth, that would be 1.29. Just to do a quick check, I can store this as, say, a, and I can do 6 raised to the 2a minus 1. Whoops. And I will get nothing because I have to put the 1 in again. So I have 6 to the 2a minus 1, and I have 9 to the a. Just to kind of quickly check this, 9 to the a, and I get 17.11, so I did it correctly. Okay, awesome. Good stuff. Onward to number 4. All right, so we have log base 4 of x minus 7 plus log base 4 of x plus 5 equals 3. There's a property of logs that says if I'm adding 2 logs with the same base, that I can consolidate that into 1 log by multiplying x minus 7 times x plus 5. This sort of makes sense. If I have log of 100 plus log of 10, this is the power that I raised 10 to get 100. Well, that's 2. This is the power that I raised 10 to get 10, which is 1. 2 plus 1 is 3. And if I take 10 to the third, that's 1,000. That's 100 times 10. So it makes perfect sense that this is equal to log of 1,000, which is 100 times 10. Anyway, back to the original equation. Once you consolidate this into 1 log, you then can rewrite this as we did in question 1. So I have 4, my base, my power to the third equals x minus 7 times x plus 5. And we get another quadratic to solve. So 4 to the third is 64. Distribute this out. We can't set each of these factors equal to 4 to the third because 4 to the third is not 0. So we just kind of do this out. So I have x squared plus 5x minus 7x minus 35. So I get 64 equals x squared minus 2x minus 35. I'll subtract 64 from both sides. And so I end up getting 0 equals x squared minus 2x minus 89. Oh, sorry, minus 99. What am I doing? Minus 99. I'm thinking 89 is prime. That's not going to work very well. Okay, so back here we are. So I'm looking for 2 numbers that add up to negative 2 and multiply to negative 99, and that would be minus 11 and plus 9. So x could be 11 or x could be negative 9. We need to be careful with domains here. My original equation is log base 4 of x minus 7. If negative 9 is x, negative 9 minus 7 is negative 16. Logs are not permitted to eat negative numbers. So this guy is out. He's not in the domain of the original 2 functions, so I'm rejecting him. And just to check the 11, log base 4 of 11 minus 7, I'm going to do the check here, just so you see how this works, plus log base 4 of 11 plus 5, is that really 3? Well, let's see. 11 minus 7 is 4. Log base 4 of 4, I ask what power of 4 gives you 4, and I get 1. Log base 4 of 11 plus 5 is log base 4 of 16. What power of 4 gives you 16? That's 2. And 1 plus 2 is 3. So 11 is the only answer. Be careful here. This is the only solution. Okay? All right, onward and upward. Number 5. I have 3 ln of 2x minus 4 equals 17. I want to get the ln of whatever by itself. So I'll add 4 to both sides. I have 3 ln of 2x equals 21. Still trying to get that ln by itself. I'll divide by 3. And so I get ln of 2x equals 7. ln is log base e. And for those of you who need a reminder, e was a special constant. It's about 2.718. And we discussed where it comes from and everything way back when we did compound interest. So now I have e to the 7 equals 2x. And I'll divide by 2. And x is e to the 7th over 2, which you can actually keep as an answer. If you wanted to round it to the nearest hundredth, pop it in your calculator. But you can keep e to the 7th over 2. All right, number 6, I have log base 4 of x squared plus 3x minus log base 4 of x plus 5 equals 1. As before, we saw 2 logs being added, and we were permitted to multiply. Now we have logs being subtracted. We're permitted to divide. So I can take the 2 arguments inside each of the logs and divide them. like so, to make 1 log. 2 logs is no good for an equation. You got to get that down to 1 log. And now we can rewrite this as 4 to the first equals x squared plus 3x over x plus 5. And so I have 4 equals x squared plus 3x over x plus 5. I could put this over 1 and cross multiply. So I would get x squared plus 3x equals 4 times x plus 5. And I get another quadratic to solve. So I get x squared plus 3x equals 4x plus 20. Subtract 4x and 20 on both sides. And so I will get x squared minus x minus 20 equals 0. This is factorable. It factors into x minus 5 times x plus 4. And so x would be 5, or x could be negative 4. We have to check. If I plug in my 5, I'm good. I have 5 squared plus 3 times 5. That's 25 and 15 is 40. Log base 4 of 5 plus 5 is 10. And log base 4 of 40 minus log base 4 of 10 is log base 4 of 40 divided by 10, which is log base 4 of 4, which is 1. So that works. So the 5 works. The negative 4, we have to also check that. So I get negative 4 squared plus 3 times negative 4, which is 16 minus 12, which is 4. And I get log base 4 of negative 4 plus 5, which is 1. Log base 4 of 4 is 1. Log base 4 of 1 is 0. So that also checks. So this time we could keep both of them. So this time both x equals 5 and x equals negative 4 work. Okay, next one we have log base x of 4 is 2/3. And again, this one I can just rewrite off the bat. I have x to the 2/3 equals 4. And we learn how to solve an equation where you have an exponent as a fraction. We can raise both sides to the 3/2. So I get x is the square root of 4 cubed. Now, normally when we solve an equation like this, I need to account for plus or minus here because I'm taking the square root of an even indexed root. And if I take these numbers and cube them, I'll get plus or minus 8. However, we're going to reject the negative 8 because logs cannot have negative bases. Logs cannot eat negatives. Logs cannot have negative bases. So our only solution here is x equals 8. Just keep in mind, though, that's the only solution. Just keep in mind, if we were just solving this equation, that equation would have 2 solutions. But the log equation does not, it has 1. All right, number 8, we have 3 times 2 to the 3x plus 7 is 25. I can subtract 7 on both sides. I get 3 times 2 to the 3x equals 18. Divide by 3. I get 2 to the 3x equals 6. And again, 2 and 6 are not in the same family. So we're stuck taking logs here on both sides, which is just fine. It's a little longer. And I can bring down the 3x, so I can do 3x log 2 equals log of 6. And divide both sides by 3 log 2 to get the x by itself. Hold on a second here. So I get x is log 6 over 3 log 2, which you could leave by itself, but if you're rounding to the nearest hundredth, we can throw that in the calculator. Alpha y equals enter. We can go log 6 over 3 log 2, and I get 0.86, which you can also check on the calculator. Okay? All right, number 9. We want to evaluate. We're not solving, we're evaluating now. I know the directions are on your sheet. Without a calculator, e to the ln of 7 minus 3 e to the 2 ln of 3. Let's understand what ln of 7 is. ln of 7 means log base e of 7. Okay, and let's just call this x for a second. If I were to rewrite this, this would say e to the x equals 7. In other words, log base e of 7 is the power we raise e to get 7. So e to the ln of 7, I'm taking e and I'm raising it to the power that I'm supposed to raise e to get 7. I get 7. I know that's weird, but e to the ln of 7 is just 7. ln of 7 is the magical power that I raise e to get 7, and we're actually doing that. Similarly, I have 3 e to the 2 ln of 3. There's a property of logs that says this number can come back up, and we actually used that in reverse before when we brought down the power. But now it's useful to go the other way. So I have 7 minus 3 e to the ln of 3 squared, which is 9. And e to the ln of 9 is just 9. So now I have 7 minus 3 times 9. Again, I'm taking e and I'm raising it to the magical power that I raise e to get 9. So I have 7 minus 27 here, which is negative 20. All right, number 10. We have 4 to the log base 6 of 72 over 4 to the log base 6 of 2. Log base 6 of 72 and log base 6 of 2 are not really easily manipulated right now because 72 and 2 are not in the 6's family. But we have 4 to these powers. So what I can do is I can write 4 to the log base 6 of 72 minus log base 6 of 2. That's what you do with powers. So for example, let's say I had x to the 9th over x to the 6th. This would be x to the 9 minus 6. That's what we're doing here. So now I have 4 to this power. This power can be simplified. I have 4 to the log base 6 of 72 divided by 2. That's a property of logs. When I have the subtraction of 2 logs with the same base, I can divide the things that are in the logs. So I have 4 to the log base 6 of 36. And 36 and 6 are in the same family. So log base 6 of 36 is asking what power of 6 gives you 36? Well, that's 2. So now I have 4 squared, which is just 16. I like that question. That question is simple, but it's got a lot going on to it. All right, off we go on to number 11. So we have log base 5 of 5 cube root of 5 minus 2 log of 1 over 100 cube root of 100. This was a rough question for some of you when we did it. But basically, it's not so bad. So we have log base 5. And I really have to convert these 5s to powers of 5. So 5 is 5 to the first times cube root of 5 is 5 to the 1/3. Okay? Well, now I have log base 5 of 5. 1 is 3/3 plus 1/3 is 4/3. So now I have log base 5 of 5 to the 4/3. In other words, what power of 5 gives you 5 to the 4/3? Well, the answer to that question is 4/3. Another way to do this is to drop this down in front and say now I have 4/3 times log base 5 of 5. What power of 5 do I raise to get 5? It's 1. 1 times 4/3 is 4/3. All right, that takes care of that part. Now I have minus 2 log base 10. Remember, if a log base is not written, it's a 10. Of 1 over 100 is 10 squared. So I'm going to convert these right off the bat. And the cube root of 100, just to look at it like this, is 100 to the 1/3 power. And 100 is 10 squared. So this is now 10 to the 2/3 power. That's going in the bottom. And so now I have minus 2 log base 10 of, well, I have 2, which is 6/3. 6/3 plus 2/3 is 8/3. But they're all in the denominator. So this is really 10 to the negative 8/3. I know I did a lot there, but you can go back and review that. So now I have minus 2 times log base 10 of 10 to the negative 8/3 is just negative 8/3. That's the power that I'm raising 10 to get 10 to the negative 8/3. All right, now I have to consolidate this. So I have 4/3 minus, well, actually, negative times a negative is a positive here. So I have 4/3 plus 16/3. And so I get 20/3 as my final answer. Remember, 2 times negative 8 over 3 is 16 over 3. All right, number 12, I have 1/2 log of 400 plus log of 200 minus 2/3 log of 8. So I have to consolidate this because these are all log base 10s, but nothing here works in 10s. So first things first, I can bring powers up. So now I have log of 400 to the 1/2 plus log of 200 minus log of 8 to the 2/3. So 400 to the 1/2 is simply the square root of 400, which is 20. So now I have that down to log of 20. I still have log of 200 here. Nothing I can really do with that at the moment. And then 8 to the 2/3 is the cube root of 8 squared. So it's easier to do the cube root first because it gets a smaller number. Cube root of 8 is 2, and 2 squared is 4. So now I have this. Okay. So how do I handle this? It's still not anything with log base 10. Well, what I can do is consolidate this into one log. My additions of logs I can multiply. So 20 times 200 is 4,000. And I'm dividing that by 4 because I'm subtracting the log of 4. So I made this into one log. So now I have log of 4,000 divided by 4, which is log of 1,000. And 1,000 is a power of 10. You should recognize that 10 to the third is 1,000. So all this mess just comes out to be 3. All right, good stuff. Number 13, we want to graph the function f of x equals log base 2 of x plus 3 plus 1. We want to state the domain, the range, and the equation of the horizontal asymptote. So just a refresher here, log base 2 of x is the inverse of 2 to the x. So 2 to the x looks like this. I'm just having a hard time reading my axes here. Okay, so we have 0, 1, 1, 2, 2, 4, 3, 8, 4, 16. And this would be the graph of 2 to the x. Be careful, I haven't graphed the log yet. This is 2 to the x. The inverse of this graph is log base 2 of x. I'm going to graph that in blue. So 0, 1 becomes 1, 0. Sorry, I just got lost for a second. 1, 2 becomes 2, 1. 2, 4 becomes 4, 2. 3, 8 becomes 8, 3. And I hope that we see the horizontal asymptote turns into a vertical asymptote. And we get something that looks like this. This would be the graph of log base 2 of x. So this guy is log base 2 of x. So I'm actually going to now erase, well, you know what, we can keep it on there. So now I just have to look at what this guy is doing. Log base 2 of x plus 3 plus 1, which I'm going to graph in red, is just a transformation of the blue graph. It's a transformation 3 back, so 3 to the left and 1 up. So I'm going to take this graph. I'm just going to put it on a cloner here, okay? And I'm going to take this graph, and I'm going to move it literally back 3. So 1, 2, 3. Okay, there it is. And move it 1 up. And that guy, I'm going to color him red. Nope, I'm not putting sound. I want to color him red. Properties. Color him red. Hey. Okay, there we are. This guy is the log base 2 of x plus 3 plus 1. So just by transformations. Okay, so domain. Well, now my vertical asymptote is at x equals -3 because everything shifted back. So my domain is everything past -3, but not including -3. -3 makes that log undefined because log base 2 of -3 plus 3 is log base 2 of 0, which is undefined. The range is all real numbers. This thing can go all the way down and all the way up. It slowly climbs up and up and up. So the equation, this should say vertical asymptote. Excuse me. That's a correction I have to make. This should be x equals -3. Okay, 14, here we go. 14 is a big one. So the amount measured in milligrams of a radioactive element after T days of decay is modeled by this function. Explain the real life meaning of 500. Well, if I throw 0 in for T, I get 500 times 0.926 to the 0. 0.926 to the 0 is 1, so I get 500. So 500 is the amount of radioactive element in milligrams when T is 0. In other words, it's the initial amount of the radioactive element. Okay, so it says explain the real life meaning of 0.926. Well, 0.926 is the growth factor. So for example, if I put in A of 1, I would get 500 times 0.926 to the 1. So this would mean I'm taking 92.6% of 500, and that's how much I have after 1 day. So it's this number is really the rate per day of radioactive substance left, or remaining. Maybe I should say remaining. Remaining after the decay. Okay. Part C says I'd like to find the half-life. Okay. Well, half-life is the time it takes for a radioactive substance to decay to half of the initial amount. In other words, I want the amount to be 250. So I'm going to solve an equation. 250 equals 500 times 0.926 to the t. And you could solve this algebraically. I'm actually going to do it graphically. So here we go. I want to plug in my graphing calculator. I'm going to clear out whatever I have in there. And I'm going to plug in 250 on one of the y's. And the other y is going to be 500 times 0.926 to the t, or to the x. Now, when I do this, I have to make an appropriate window. So my x min, well, I can't have negative time, but I'm going to put a little negative time in here so we can see the y-axis. And x max, I'm just going to put in 20 and see where we go from here. My y min, again, I want to see the y-axis, sorry, the x-axis a little bit, so I'm going to put in like negative 10. And I know my decay starts at 500, so I'll put in a little bit bigger of 5. I'll put 510 in. And let's just see how this does. There's my straight line, and there's my decay function. That's nailed it perfectly. Now what I want to do is grab that intersection point. So I'm going to press second, trace 5. First curve, press enter. Second curve, press enter. And the guess, scroll over to it, roughly. And I get 9.0158398. And they asked me to round to the nearest tenth. So this would be, I'm going to just grab this. This would be my graph. Let's cover up the other graph that I had on paper. You can draw this out at your leisure. There's my graph. And I get, I'm going to round this to the nearest tenth, so that'll be 9.0. And part D says the function a of t can also be written as 300 times 0.5 to the t over k. What is the value of k? I hope you notice now the amount left over, the rate at which the amount left over is 0.5, meaning that k should be the half-life. So this is pretty simple. A of t equals 300 times 0.5 to the t over 9. Just to see why this is true for a second. If I plug in 9 for t, I get 300 times 0.5 to the 9 over 9. Well, 9 over 9 is 1, meaning that I'm just going to multiply, I didn't mean 300, I meant 500, sorry. I'm going to multiply 500 times 0.5, and I'm going to get 250. And we know that happens when t is 9. So k has to cancel that t out. In other words, this k has to be the half-life, and that will cancel it out. Okay, the function a of t can also be written as 300 times, oh, that's why I'm doing the 300. Oh boy, so hold on a second. I apologize. On the worksheet, this should be 500. This should be 500. I'll tell you guys that today in class. That's why I was getting 300, excuse me. So the function a of t can also be written as 500 times 3 over 4 to the t over k. What is the value of k? Well, again, as this was the half-life, this k would be the 3/4 life. In other words, when is there going to be 3/4 of the substance left? So I'm going to go back into here, and I'm going to have, instead of 250 here, I'm going to have 3/4 times 500, which is 375. Okay, so I'm really solving this equation now. 3/4 of 500 equals 500 times 0.926 to the t. And that t value is going to be the value of k that I need. So I'm going to graph that again. Whoops, sorry. I'll graph that again. Go away. Go away. I'll graph that again. There's my line. It's moved up a bit. And there's my exponential decay function. And I'm going to find out where they meet again. So second trace 5. First curve enter. Second curve enter. And the guess, intersection point, I got 3.74. All right. So this guy, K should be, so A of T could be written as 500 times 3/4 to the T over 3.74. And explain how we found our answer for K is just the amount of time it takes for the radioactive substance to decay to 3/4 of its original value. All right, let's see. F. F says the function A of t can also be written as this. Find the number in the blank. Okay, this one's a little trickier. So if I look, so A of t is 500 times 0.926 to the t. Well, what I have is t minus 8. So I have 500, and I have 0.926 to the t minus 8. So if I think about what has to go here, this exponent that I'm going to put in the green box plus t minus 8, so the green box exponent plus t minus 8 has to be equal to t in order for these things to agree. Well, therefore, the number 8 has to go in the box. And my base is going to be 0.926. So just by properties of exponents, 0.926 to the 8 times 0.926 to the t minus 8 gives us the t. So now this number, 500 times 0.926 to the 8, is the number that goes in the box. So that's 500 times 0.926 to the 8th power goes in the box. And that's 270.31. And what is the meaning of that number? Well, that number is the amount of radioactive substance left after 8 days. I believe we're in days here, right? We are in days. So the 270.31 is the number of milligrams of the substance left after 8 days. And that's why this is t minus 8, because 8 days have occurred already, in other words. All right, off we go. So number 15, we have to simplify. This is from unit 6 now. 2 over x plus 3 plus x over 1 minus x plus x plus 2 over x squared plus 2x plus 3. We are simplifying an expression. You need to be careful. We are not solving an equation. We want denominators. We do not want to cancel denominators. Importante. We want denominators. We just have to get a common denominator here. So I have 2 over x plus 3 plus x over 1 minus x plus x squared plus 2. And I'm going to factor this denominator. So I'm going to get x, what do we have here? I'm getting a little tired. Plus 3 times x minus 1. And now it's very noticing here, 1 minus x and x minus 1 are opposites. So what I can do is I can write this as x minus 1 as long as I change the sign, and I can change the sign on the top to make the fraction negative. So now it's just a matter of multiplying each fraction by what the other has that it needs. So this first fraction, 2 over x plus 3, I have to multiply by x minus 1, top and bottom. The second fraction needs an x plus 3. And the third fraction needs nothing. So I'm going to have 2 times x minus 1 minus x times x plus 3 plus x squared plus 2 all over x plus 3 times x minus 1. Now I'm going to expand the numerator, but I'm going to leave the denominator alone because I like the denominator as a factored form here. So I'm going to distribute my numerator. So I get 2x minus 2 minus x squared minus 3x plus x squared plus 2 over x plus 3 times x minus 1. All right, in my numerator, I have some simplifying to do. The x squareds cancel, these 2's cancel, and I end up getting 2x minus 3x, which is negative x, over x plus 3 times x minus 1. I'm going to leave it alone. I don't have to distribute the denominator out. Typically, if you did, sometimes you can get a factor in the numerator that cancels. In this problem, we don't. Okay, number 16. Find the solution set of the inequality x squared minus 6x plus 9 over x squared plus x minus 2 is greater than 0. So we talked about any inequality. What you want to do is solve the equation, the related equation. And we also want to find undefined points. So my related equation would be x squared minus 6x plus 9 over x squared plus x minus 2 is equal to 0. And if I put 0 over 1 and cross multiply, I just get x squared minus 6x plus 9 is equal to 0, which factors into x minus 3 times x minus 3. So x is equal to 3. That makes the fraction equal to 0. The other place where signs can change are where the fraction is undefined. So I have x squared plus x minus 2 is equal to 0. So I'll factor that down into x plus 2 times x minus 1 equals 0. And I would get x equals negative 2 and x equals 1. These are places where the fraction is undefined. Now what I want to do is put these on a number line, because I want to figure out when this quantity is greater than 0. These kind of give me the borders. So I want to put everything on a number line here. And here are the values that go on my number line. Negative 2, because it made the fraction undefined, 1, and 3. And now what I can do is plug test values into the inequality. So I want to take negative 3, for example. And I'm going to plug it in. So actually, let me highlight. I'm going to break this number line up into chunks. And I'm going to test each chunk. So here are my chunks. Test each chunk. Okay. So I'm going to test the green chunk. I'm going to plug in x equals negative 3. Negative 3 squared minus 6 times negative 3 plus 9 over negative 3 squared minus negative 3 minus 2. Negative 3 squared is 9. Negative 6 times negative 3 is 18. So I have 9 plus 18 plus 9, that's 36. Over 9 plus 3 minus 2, that's 12 minus 2 is 10. 36 over 10 is 3.6. That is greater than 0. So this chunk stays in the number line. All right, I'm going to test my blue chunk. I'm going to plug in 0 because it's easy. 0 into my x's. I get 9 over negative 2, which is less than 0. So this chunk does not work. Okay, now I'm going to test out a number on the pink chunk or purple chunk, which is, I'll call it 2. So I'll plug in 2 here. 2 squared is 4. 6 times 2 is negative 12. So I have 4 minus 12 plus 9. I get 1 on the top. On the bottom, I get 4 plus 2 is 6, minus 2 is 4. So I get a fourth. That chunk works. And 3, I'll test 4. Whoops, sorry. Time out here. I didn't mean to do that. Okay. Not having a good day at the smartboard here. And then I'm going to test 4. So I have 4 squared minus 6 times 4 plus 9 over 4 squared plus 4 minus 2. So I get 16 minus 24 plus 9 over 16 plus 4 minus 2. 16 minus 24 is negative 8, plus 9 is 1. 16 plus 9 is 25, minus 2 is 23. So I'm over 0 there. So I have 3 out of the 4 numbers chunks work. Negative 2 does not work because it makes the fraction undefined. 1 does not work because it makes the fraction undefined. And 3 does not work because it makes the fraction equal to 0. And so now I get 3 separate chunks that I can write out in interval notation. So I can write the first chunk as negative infinity to negative 2, union 1 to 3, union 3 to infinity. I have to skip the 3. And this would be my solution set to the inequality. All right, so I'm going to simplify this complex fraction. We have 3x plus 2 over x minus 1 minus 8 over x minus 4 equals, over this whole thing. So again, I want to simplify. I want to potentially keep denominators, but I don't want to keep denominators in each of the numerator and denominator of the big fraction. So I'm going to I'm going to factor out the x squared minus 5x plus 4. That factors into x minus 4 times x minus 1. So now I can multiply top and bottom of the big fraction by x minus 4 times x minus 1. In other words, I can zap out. I can zap out the baby denominators by doing this. And by the way, I'm keeping the fraction the same because I'm doing this multiplication to the numerator and the denominator of the big fraction. So I'm going to cross out my x minus 1. So I get 3x plus 2 times x minus 4 in parentheses minus the x minus 4's cancel here. So I get 8 times x minus 1 all over the x minus 4's and the x minus 1's cancel. And I get 2x squared minus 12x. Now I have some work to do here. So I'm going to distribute. I have 3x squared minus 12x plus 2x minus 8 minus 8x plus 8 over the bottom. I'm going to factor. I can factor out a 2x and be left with x minus 6. So let's see what at the top brings us here. So I have 3x squared. Negative 12x minus 8x is 20. Negative 20x plus 2x is 18x. And it should be negative, excuse me. Negative 8 plus 8 is 0. Okay, so that's cool. And I have 2x times x minus 6 on the bottom. So the top factors, you could factor the 3x and be left with x minus 6 over 2x times x minus 6. The x minus 6's cancel, and the x's cancel, and all of that big mess turns out to be 3/2. Okay, I'm going to do one more, and I'm going to leave the video lesson. I'm going to do the word problems on a different video lesson because I actually have to go. So bear with me here. So we're performing the indicated operations and simplifying the result. So I have, first thing I'm going to do here, write this out. So multiplying fractions is good to go. So I'm going to write that out. And then I'm dividing here. So I'm going to multiply by the reciprocal, which is 16 minus x squared over x squared plus 2x minus 8. Now, when I look at this, really what I have to do is factor and cancel. So for example, if I was doing 3/5 times 10 ninths, right? I could say, well, 10 is really 5 times 2 and cancel out the 5s. And 9 is really 3 times 3 and cancel out the 3s. That's exactly what we have to do here. So I'm going to factor this first guy. I can factor this guy by grouping. I can group the terms together. So I can factor out an x squared from the first group, and I get x minus 3. I can factor a 6 from the second group and get x minus 3. Over, on the bottom, I can factor out an x. We'll come back to this guy on the top first. So I have 2 times x minus 2 over x cubed times x minus 3. And then I have 4 minus x times 4 plus x by dots. And I'm going fast here because this is stuff you guys should be able to knock out pretty quickly. And I have x plus 4 times x minus 2. On the top over here, we still have to factor out the x minus 3. So I have x minus 3 times x squared plus 6 over x times x minus 4 times 2 times x minus 2 over x cubed times x minus 3 times 4 minus x times 4 plus x over x plus 4 times x minus 2. And now I just have to look for cancellations. So I have one here. I have x minus 3 is gone. I have another here. I have x minus 2 is gone. I have a 4 minus x and an x minus 4, which becomes negative 1. And I have a 4 plus x and an x plus 4. And this is where people mess this up. 4 plus x and x plus 4 are identical. No negative 1 there. So now I just got to collect what I have here. So I have, on the top, I have my x squared plus 6. I have the 2. I have the negative 1. So on the top, I really have negative 2 times x squared plus 6. And on the bottom, you just got to be careful when you collect this. I have x and x cubed, which is x to the 4th. And I can leave that by itself. Okay, like I said, I'm going to do the 2 word problems on a separate video. Thanks, guys.